So, next talk, Pragmatic Security Automation and DevSecOps in the Cloud by Joshua, the CTO of NuWorks Interactive Labs.
All right, thank you. So thank you again for inviting me here. So my topic for today is pragmatic security automation and DevSecOps in the cloud. So again, this is going to be a very quick talk, but you'll definitely learn a lot of techniques, especially things that you can apply to your professional career or at work. So to introduce myself, I am Joshua Arvin Lat. People call me ARVS, ARVS. I am the Chief Technology Officer of NuWorks Interactive Labs, and I'm an AWS Machine Learning Hero. I'm also the author of the book Machine Learning with Amazon SageMaker Cookbook. So feel free to check this out, especially if you want to learn how to do machine learning in the cloud. So enough about myself and enough about the book. It's now time we talk about the topic. So before we talk about how to secure things, before we talk about how to improve your automation workflows, the first thing we need to check is our understanding of how hackers or crackers attack systems or how they attack companies or entities. So we talk about cybersecurity attack chain. It's hard to defend something, especially if we have no idea on how to attack it. So one of the ways to understand how to prioritize which ones to process and secure, we have to check which ones are easily available for attacks. And sometimes attacks may not be straightforward. Sometimes attacks require a sequence or a sequence of steps, which basically involves exploiting different services or different opportunities of especially those that are considered as vulnerable, even though these vulnerable opportunities may not be exploitable by themselves. For example, let's say that we have a network infrastructure like this. We have a DMZ setup. So we have a public subnet here in this area, which is available from the outside world. And then this one, we have a private subnet where this private subnet contains, let's say, the databases, or this one contains other instances or computers. So when trying to process and analyze the potential vulnerabilities and areas for attacks, we identify which ones are available in the public subnet. Because even let's say that the IP addresses are not in, let's say, the DNS configuration, it's still best to assume that these are still prone to attacks because hackers may randomly figure out the IP address or basically how and be able to access your instances. So do not assume that your computers or servers are safe, especially when they are exposed. Even though you're not explicitly telling the world that these instances are available. Yeah, so usually some of the instances which may be used to control other servers or maybe used to configure other systems, those are usually forgotten when it comes to securing the entire system or application. So it's very important for us to understand that any new system added needs to be properly secured and hardened. So we tag which ones are of high risk, and then we try to assess. And we try to perform vulnerability assessment tests and even penetration tests when needed to just secure both production and staging resources. So why is this important? In the ideal world, in the ideal sense, whenever we're trying to build a company, when we're trying to build when trying to build systems, usually we try to assume that everything will go perfect. So if you look at the screen, we have here right now, let's say, the goals. Let's say we have the financial objectives of a company. We have the long-term financial objectives of a company. We also take care of the client and customer happiness and compliance. So this usually is the high-level list of things that teams take into account when trying to build something or when trying to provide a service. So yeah, again, ideally, these are all equal. These are all considered as high. However, because of limited resources, because of time constraints, because of the different challenges and blockers that your team might experience, this is how it might look like in the real world. So for example, now in the pandemic, we all know that things got a bit trickier. The game became harder. And the security and compliance aspects always get deprioritized. So even if people understand the importance of why we need to secure systems and why we need to take care of the security of our company, this usually is what happens. This is how companies solve requirements. And again, they deprioritize compliance and security requirements. Because a company will not survive if it's not able to take care of its short-term financial and long-term financial objectives. So let's be real here. Will companies prioritize security, or will they prioritize the financial aspects first? Of course, financial aspects would be prioritized, and security and compliance would be deprioritized. So that said, it's about being able to balance time, being able to balance the resources, being able to manage everything so that we're able to take care of the things we need to take care of. So there's something called due diligence, which is usually forgotten whenever people are distracted or focused on trying to fight fire, or basically they're dealing with firefighting work. So when dealing with security requirements, it's important for us to think about the feedback loop. A lot of the things that we need to deal with usually has something like this, but we usually end up forgetting that something like this exists. So one example of this would be the development lifecycle. Whenever we build something, we try to wait for 3 months before our product gets tested by the stakeholders or the sample users. So when we try to have a longer, or what's the proper adjective for it? When we have a larger or longer feedback loop, the problem there is that we don't have an opportunity to fix the problems right away. We try to wait until the end. And usually it's hard to correct the mistakes, especially if we're getting the feedback at the end. So the goal there is to divide, let's say, a larger plan into, let's say, 3 parts, and then there should be feedback already in the first part, in the MVP. And then in the second phase, there should be feedback, and so on. And then this applies the same way as with the security aspect of systems. Let's say that you have a 3-month project. If we were to wait for 2 months or 3 months for the project to be completed, only to realize that the libraries and some aspects of the system, the framework, the version of the framework that you're using has this sort of vulnerability. And this vulnerability can easily be exploited by attacks. So the problem there is, if the feedback loop happens at the last part, then what might happen is the team might be forced to replace an entire chunk of work, and there's wasted work already. If there's feedback earlier in the process, then we would be able to solve and mitigate the security vulnerabilities ahead of time. This seems simpler than how it sounds. However, in terms of implementation, this is hard to fix, especially if the tech team, the development team, is not able to work with the IT security team right away. So the technical heads or the CTOs need to be aware of this challenge, and it's all about managing the time, the timings, and managing the resources so that we'll be able to solve these challenges before we detect it. So this is where the pipelines come in. Usually when trying to develop something, when you're just a team of 1 developer, usually development teams start like that. There's one developer or 1 engineer assigned to complete the entire project, let's say for 2 months. Usually when you're a single developer, you will not need a more rigid set of processes. You will probably be able to survive by following a very loose development process. But when the team grows to, let's say, 3 or 4 people, and then the project will be used by 10,000 customers per day or 10,000 users per day, you will definitely need a more rigid process, and you will need to be able to manage the security, performance, and the quality of the output. So you'll probably have something like this where you push the code, and then there's an automated pipeline which gets triggered, and it builds the code first, builds the artifacts, and then there are probably some automated tests which are going to run to check if there's going to be regression and if all the different special cases are handled well. And then before deployment, you might need a manual approval step where, let's say, a manager or someone from your team is able to analyze first and check if this current build is ready for deployment. So again, This may or may not be supported by your CI/CD pipeline, but this is usually the way to go whenever we're dealing with more complex set of requirements, especially those that have heavier back-end work. So where does security come into play here? Usually in much larger companies that still follow the old and traditional ways of securing applications, usually security happens at the last part. And the challenge when you're trying to assess the application after 3 months, whenever it's close to the deployment date, is that when vulnerabilities are detected, usually they are just patch, and the patch solutions are not really the best solutions and not really the long-term solutions needed by your application. So if security has been shifted to the left side, meaning if let's say you push the code and then some security tools are already running, after pushing the code, then reports may automatically be generated and your team may be able to process the reports and fix the problems right away, let's say in the second week of development. This allows the team to properly adjust the timeline and properly take into account the discovered vulnerabilities without trying to work on new modules on top of a core platform which already makes use of, let's say, a deprecated library or deprecated framework version. So again, the earlier we're able to detect the problems, the better. And at the same time, if we can automate some security work, then that's better also. Because trying to reserve the time of IT security specialists and professionals is tricky, especially if there's a lot of projects happening and being executed all at the same time. And that's not, and auditing your code is not the only work being done by the IT security professionals. They'll probably be auditing the other systems. They'll probably be worrying about compliance and so on. So again, we divide the work into what's automatable and what's manual, and then we'll try to automate and include the process as early as possible so that developers and the engineers are able to fix the problems right away.
Hi, we are Eficode and we organize the DevOps Conference. We think that DevOps solves the conflict between security and the rate of innovation. If you are burdened by compliance, regulation, and red tape, we would love to talk and help you with your next steps. You can find us at eficode.com. The links are in the description, and have a great time with the DevOps Conference talks.
All right. So this is one cool solution that I was able to implement a few years ago, maybe 7 years ago, in my previous company. So this one is something called the automated data integrity layer. So what is this all about? So whenever we're talking about security, usually we only talk about firewalls. We only talk about the different layers. Whenever we try to secure the application side, we're trying to secure the database side, and how to access the network components. However, we need to take a step back and understand, how are hackers able to attack our systems? Usually when they're attacking a complex system, they're trying to accomplish something. And what is that? One of the things they may want to do is either steal the data or modify the data directly in the databases. So let's say that there's an application tier, and then there's that database tier. If the hackers are able to attack and compromise an instance containing the application tier, it's best to assume that that instance has already been compromised, and the next step there is to attack the databases. So there are different ways to attack a database, whether it's directly, indirectly, and so on. But usually, they may try to modify some of the values there so that if a user is accessing, let's say, a mobile app or a web app, and that web app or mobile app interacts with a database, a system that connects to a database, then that user may end up having 1 million credits because the values have already been modified behind the scenes. So having an automated data integrity layer would help detect things in real time. So usually when you have a security tool, what happens there is that the security tool tries to look for vulnerabilities in your system. That's usually how security tools work. And let's say that the security tools are running, let's say two weeks after a certain project has been completed, it will not be able to detect the problems in real time unless that you're using some sort of real-time network firewall or some sort of application security tool. But the database is usually forgotten because we're taking care only of the security part, the server. So what we're trying to do here, is we're trying to check if 1 + 1 = 2. So again, this is a very, very simplified example, but usually the formulas should look like this. If A + B = C, and if you have some way to log the real transactions properly, if a hacker directly changes the value of 2 and changes it to 2 million, so let's say that the credits would be two credits, right? And then suddenly this became 2,000 credits because the hacker edited this directly. Then your application layer should be able to detect this value change. Therefore, let's tag this as a malicious. This row is already tagged as something which has data integrity problems, which you can immediately check the same day or within the week. And you can try to potentially block all transactions with related to this row. So this is one of the ways to do this, because if you were to try to use a separate system, this would be hard to track. But if you were to implement this automated data integrity layer inside the actual web application, then you'll be able to be creative when it comes to detecting these problems and these mistakes. So you would be able to detect bugs, and you would be able to detect real attacks. So this is an example how it's going to be done. So let's say that you're using Flask, you're using SQL Alchemy, and you're using Python, and then let's say you're using Docker containers to run your application side. So regardless of the tech stack being used, you can implement and apply this strategy. So what happens here is that in SQL Alchemy or whatever ORM that you're using, you can just add an additional, let's say, 3-liner code, which just checks if what was loaded is still following the formulas and the business rules. And it may add an additional second, because adding business rules may add an additional second or two. But if these transactions happen only 5 to 10% of the time, then that should do just fine. So if there's, let's say, a transaction which involves money, then you can have something like this, because usually the traffic is 90% views or reads, and 10% would be write transactions. So you want to check the integrity of the formula and the values during the write operations only. And this is one of the ways to detect data integrity problems in real time. So the next security technique which can be automated is automated vulnerability management. So in the past, most of the tools that we've been using utilize, let's say, a scanner. And that scanner can be, there are still a lot of tools that behave like this. Although traditionally, this is how vulnerability management or vulnerability assessment tools work. You have a scanner, you have a target server, and then the scanner runs, and then there's going to be a generated report with a list of vulnerabilities. And you have to verify and check each vulnerability and check if we really need to fix the problems listed there. And one of the challenges there is that usually the developers are not trained to process security vulnerability reports. Usually you will need an analyst, a security analyst, or someone who really understands the security components. Developers are focused on building things. And developers are, let's say, trained to design systems, to design code. They're like code architects. Sometimes they're focused on animations, or sometimes they're focused on optimizing the performance of the systems. So instead of 10 seconds, you want your engineer to optimize it to 1 second. So there are a lot of things that a developer or engineer needs to study and learn, and security may not be in that list. So having someone to analyze a vulnerability report, that person may be a separate resource or someone from a different team. So doing this manually is sometimes not practical. So automating vulnerability management may be the thing for you. So how does it work? So some vulnerability assessment tools just involve installing an agent inside your servers. And sometimes agentless tools are better. But of course, it's up to you to assess because that really depends on the tool. So what happens here is that if there's a change in the server configuration, if something moves inside the server, then the vulnerability assessment tool automatically runs inside that server. And the vulnerabilities will automatically be checked, and the report can easily be shared to, let's say, an analyst, which can be part of the development team. This allows asynchronous processing of your vulnerabilities, and developers can easily just push their work, push their builds, and the vulnerability assessment tool would automatically run whenever there are changes. So again, there are different ways to use vulnerability assessment tools. The first one would be a weekly scan, or let's say a monthly scan. But one of the more practical ways would be, let's just run the assessment tools when there are changes. And developers may be able to check if their fixes or patches have worked, because if the first report reported, let's say, 100 vulnerabilities, and then the second report after the fixes and patches only reported 30 vulnerabilities instead, then that means that 70 issues have been resolved by the team without the need to reserve a security expert or security analyst to process the reports. So check if this will apply to you or your company. The next one would be the proper usage of different tools, let's say containers. So what I shared earlier would be on instances, but container images can also be processed by vulnerability assessment tools. So feel free to look for tools which can be used on container images as well. So if you're utilizing container images to deploy your application, then same banana. You will be able to process and check for security vulnerabilities of container images before deploying the containers. The next one is secure infrastructure as code. So again, this one, it's much harder to implement. But what is this in the first place? Whenever we're trying to deploy staging and production environments, and maybe even pre-prod environments, usually we try to do things manually. But as the systems become more complex, as we deal with more distributed resources, sometimes it gets trickier to make sure that our staging and production environments are in sync. So one of the solutions there is to utilize infrastructure as code, which automates the process of preparing staging and production environments. So what do I mean by that? So let's say that you have a server, and then you have a storage bucket here, and then you have this other resource. Instead of trying to create these resources manually, we can codify and convert it into code so that this code can be run or executed to create new resources. So let's say we have a template. Let's say we have a template like this, key value. So this is the resource, this is the parameter value. So let's say that the size of this instance is T3 micro. What will happen here is that if we were to run this template inside a service that converts code into real infrastructure resources, then we are sure that the desired state would look like how we defined the infrastructure in the code. So again, if we want, let's say, this infrastructure and network configuration created, we convert that into code. What happens here is that if we were to create a staging and production environment from the template, we will be able to create clones, meaning things are more predictable. And this way, if we are to secure the environment in the staging environment, we can test things properly. So let's say that the Redis server has the security group, and we know that this Redis server, if it's open publicly, this can easily be attacked by hackers, right? So what we want to do here is we want to secure the security group, which protects the server so that it's not accessible publicly. So you test it first in staging, and then if the system is still working in the staging environment, that's the time you apply the same set of changes to the production environment. So this allows for easier configuration management. And this is one of the better ways to manage very complex infrastructure, especially if your infrastructure, let's say, makes use of Kubernetes, if your infrastructure makes use of machine learning pipelines, and so on. So again, this may or may not be applicable to your use case, but when your application becomes complex and you're dealing with distributed resources, this is one thing to look at. So before we end this session, the question here is, do we automate everything? The second question here is, can we automate everything? So if you are an engineer, your answer might be, yes, let's automate everything. In real life, this might not be possible because, again, the business needs to balance things. There's always a budget. We cannot automate everything. However, let's automate everything which makes sense. If it's going to take an engineer or a professional in that company 20 days to do something, and you're able to automate it in 1 day, and yeah, there's that ROI factor. So definitely you can automate everything, but you will not automate everything. There's that difference. At the same time, sometimes you need to take a step back and understand that it may not be a technical problem at all. 50 to 70% of your problems or challenges can be solved first by looking at it from an operational standpoint and just by proper training and by sharing the information accordingly to the different members of the team. If you are able to secure your systems, it will not necessarily tell you that your entire company is secure. So make sure first that your entire company understands why we need to perform and follow certain security practices. So again, this boils back to compliance. You may have a very amazing and very sophisticated DevSecOps pipeline. However, you may still be attacked through other means, let's say phishing attacks, or maybe some other attack which is targeted towards your less technical team members. So make sure that that aspect is taken into account first before trying to spend all your resources trying to secure all your systems and trying to automate all the processes. So again, understanding the needs of each team, understanding the members of your company, and how much they understand the security process, it's critical. If somebody forgot to enable two-factor authentication and their password is password, then yeah, if somebody tries to attack your company, then everything that you've worked hard for may be gone in a second. When trying to study about tools, it's also important that your developers are trained also when it comes to the tools that they're using. A beginner level developer may be able to build something. An intermediate or advanced level engineer may be able to create production-ready configuration. However, if you're dealing with a really complex production-level application, and that application is, let's say, a banking application, something which involves payment gateway integrations and so on, you will need an expert who is capable of securing and scaling your current configuration. Because once your application becomes famous and a lot of users are using it, expect attackers of all types to try and break your system. And finally, if all you have is a hammer, everything becomes a nail. So before choosing the tool, make sure to research all the tools available, because once you select a tool, you're generally stuck with what you have. Even if you say that, oh, this is agnostic to this whatever framework, you will probably create something from scratch again if you decide to replace the tool with something else. Yeah, so again, choose the tools properly, perform proof of concept work, and do not believe all the marketing materials that you read, because sometimes some details are left out. So it's critical to properly assess the tools that you use. So that's pretty much it. It's a very straightforward and short topic, but hope you learned something from my talk.
Thank you for being here, Joshua. And thanks for the great talk.